this last presentation. It will be 3D geospatial application development with no internet access by Kristyna Krickova. Okay, whenever you want.
Thanks for the word, and welcome to this talk. With my talk, I will continue with the topic of the VTS. And my name is Tina, and I'm from the Melon Technologies. So first, what am I going to talk about? I will talk about the drawbacks of the cloud, then going offline with the VTS, and then say something about the VTS architecture, how to install and how to set up the software. And in the end, I will show you some short demo. So nowadays, the many application works with the cloud, and the reason is quite simple. It's because the work with the cloud makes work with the resources easier for the users, because the resources are just available and they do not require any other attention from the user. And that's a big advantage, especially in a case with work with potentially large resources, like the 3D data sources and these things. And the biggest advantage of the cloud, of course, is that we are able to work from almost everywhere. However, there are still some points which complicate the work with the cloud. The fact you don't have to take care of the resources usually means that you cannot host your resources, or it's not so easy to combine your own resources with the ones in the cloud. So all the resources have to be uploaded to be usable. And the biggest disadvantages, especially for the purposes of the presentation, is that the cloud depends on the internet connection. The fact cloud needs the internet connection means that there are cases where the work with the cloud is excluded. One such an example might be the disaster management. In case of some nature disaster, like a hurricane, flood or something, the telecommunication or the network are first to be affected. In that case, we cannot depend on the work with internet, so the offline solution there is necessary. The same we can say about the emergency services, because their databases cannot depend on some external sources, which logically means that they cannot depend on the internet connection. And in a third case, we can say it about some legal issue or the internal company guidelines. For them, uploading data to the cloud means sharing some sensitive information. And it can be example of the Saudi Arabia and its security policy, because in Saudi Arabia all the geospatial data are considered as sensitive, so they cannot be shared, and again we cannot use the cloud. So running your own client server FOSS stack is pretty well solved in 2D for raster and the vector data. We have a geo server, map server, tile server, leaflet, or OpenLayer. But what about the 3D? The first important question is why 3D if we have pretty well solved the issue with the 2D? I was talking about the disaster management. So imagine the flood, for example. With the digitalization of the flood plans using the 3D technology, we might be able to predict the situation within a few hours in a case of the flood. On the right side, you can see the flood in Prague in 2002, and on the left you can see the 3D model, so you can easily imagine how could situation be visible. Or imagine the person mounted on the mountainside, and thanks to the 3D displaying, we would have a real data about the height of the mountains, it's nearby the forest, and we can easily find the best possible path to save time to get to the wounded person. And saving time here means saving the life. And that's the same, like when it's in the big city, the tall building in a fire, and we have all the necessary data, like the height of the building, the nearby, and we are able to find the best possible way how to evacuate people, for example. So we heard why 2D is sometimes not enough, and where the 3D solution is much better than just a 2D. So how to set up an offline 3D FOSS stack and how to upgrade your 2D stack to 3D. First, let's talk about how VTS can help us in the offline deployment. You've heard enough about the VTS, but for the purposes of this talk, let me shortly remind you that the VTS is an integrated FOSS system for 3D geospatial streaming and rendering. It has the BSD2 close license, and it was designed for standalone deployment. And it has both streaming server and the client libraries. VTS is compatible with a number of FOSS formats, standards, and services like GDAL readable raster style OGR vectors, WMS, WMTS, MVT vector styles, and for 3D it might be SLPK or VF. Now I will tell you some biggest highlights of the VTS, and the first one, it's a client. We have both. We have a desktop clients and web clients. For the desktop clients, we have ports for all the systems like the Windows, Mac OS, iOS, and the Linux. And for the web client, they are written in JavaScript and the WebGL, and in C++ and OpenGL for the desktop client. It is well documented on GitHub with the live examples. And thanks to VTS, you can measure, you can add custom vector data, like, for example, the live position. In the case of the emergency services, it's a live position of the ambulance and these things. You can query positions and so on. The next highlight is a dynamic tile generation, which means that we can save space and time while streaming large resources or DEMs, even like globe DEMs. And the VTS was actually used, the VTS is on demand and thin generation for DEMs and DSMs, but it's not limited only for them. It also works for vectors and rasters and these things. We actually streamed a 90-meter global DEM using only 60 gigabytes of a disk space, which is pretty low, and it reduced storage requirements for offline deployment. Because we do not need to pre-generate any tiles. The next highlight of the VTS, and it's data fusion. You've heard about it from my colleague Ladislav, and it's a very strong point of the VTS. Thanks to data fusion, we are able to fuse more 3D data sources, for example, DEMs, DSMs, with like 3D city models or another DSMs and DEMs. And through the fact that this fusion is running on the server side, the datasets can still be handled independently on the client. And another part of the VTS is on-the-fly translation of vector data from 2D to 3D, because most of the data, like vector and raster data, do not contain the information about the height, and so we have to enrich those data with the informations about the height. And also the next highlight you already heard, it's that the VTS is scalable and the height performance. Again, there is a picture from the mappe.cz. You've seen a previous presentation. For those who didn't heard it, who slept or something. The mappy.cz is a website with the 750,000 daily users, and VTS runs 3D here, and it's very easy to manage and streams the terabytes of 3D content. And again, server-side data fusion eases here the load on the client. So we've heard where 2D is not enough, where 3D is a better solution, where offline 3D is necessary. So we heard that the VTS is a solution for this problem, and now it's time to say how to get the VTS, how to set up, and how to use it, how I will show you on the demo. So VTS is available as a single package Debian repository, and the only thing you need is to add the, as a Debian package, and you need to add the Debian repository. How to do it is describe it on the first link you can see on the first row. And once you install and open the package, it's easy to use it how you would work with another in some other package. You can verify that the installation completed successfully on the next link, because after click on the button and this link, you will see something like this, like that. Once you have it up and running, it's time to set up the VTS map proxy and set up your own resources. VTS map proxy dynamically converts DEMs to TINs that can be streamed to and used by the VTS clients. It also takes care of translation of vector from 2D to 3D, and it also works with WMS, WMTS, or planar rasters. Again, we have many tutorials where you can see how to set up a terrain, raster, or vector map proxy resource. Once you have it, you can add your terrain to VTS storage. 3D resources defined in VTS map proxy can be added to VTS storage to be fused with the 3D cities and with one another. So you are using this tool, the VTS, at storage, so at where, then at what detail set, and in case of the terrain, we are landed to the bottom. Then we can fuse the 3D city with the terrain. So it's thanks to VTS, we have to convert the datasets like VEF or the 3D like SLPK or Lottery into VTS supported formats. And first we just input our datasets, then output it in a supported format. And then on the third row, the tilesets ID is just the name how the dataset will be known in the VTS. And then we have to add it to VTS storage to be fused with the terrain. So again, we are about to add to the storage and what, and in this case, we will land it on the top. When we have it, we have like a great base where we can build our API above of this software. We can render our live non-VTS data to the map. We can measure and interact with surfaces or create desktop and Unity applications. Or we can add styled vector data, make the vectors interactive, fuse large amounts of 3D models and terrains, or get in touch and get involved. Now I will show you. You might see this model on the previous presentation, which was handled by Ladislav yesterday. This is the model of the St. Louis, where the previous phosphagy was handed. And here you can see the result of the work in the VTS. And the best part of this presentation is that this is going completely offline from this computer. So you don't need anything to run this one. So that's all from me for now.
Okay, interesting presentation. Thank you, Kristyna. Do you have any question for this presentation? No, I think we are almost on time. So we are going to finish this session here. And now there's a coffee break. There are 20 minutes. So next session will be at 3:35 p.m. So see you in the next session. Thank you very much.